Welcome to Mr. May presents his top 5 most common mistakes found in lab assignments. We're going to go through a couple of different examples of labs. If you think you're seeing yours, you might be, or you might be seeing someone else who did the same mistake. Like I said, these are the most common mistakes I'm seeing that are causing sometimes perfectly good assignments to get zeros because of just a silly mistake that's easily avoidable. My first common mistake is having the wrong file name. So here we've got a Java file, and this was called lab1.4.java, which is not the correct file name, which means no matter what's in the file, it's not going to compile. And so it will fail all of the tests because it just didn't run. This is a mistake that's going to happen when you're copying and pasting your code from Replit to the Turnitin. So I'm going to copy this code. I'm going to go to the Turnitin. So when you go and paste your code in, it should auto-detect the file name here. Here it says it's called condition_drills.java. Don't change that. If you paste your code in and it puts a name in this box, don't change the name here. If you write anything else in this box, your code won't compile. The name that goes in there has to match this line right here, public class condition drills. That's going to be the name of the file, condition_drills.java. But if you've pasted your code into this box, it should auto-detect that name for you. So there's nothing you should change. If you're changing this right here, you're making your grade become a 0. So don't leave that alone. Less work for you. That is the first mistake and how to solve it. Easy, right? Second most common mistake, and this is in, we're going to call it 3 parts. The first part is package. So these mistakes are going to happen most likely if you are writing your code on your computer, not in Replit, but in IntelliJ or Eclipse or Visual Studio or some modern IDE that does auto completion for you. So there's this idea of packages in software, and I'm not going to get into what that is, but if you're using one of those IDEs, they're going to by default put your code in a package. And so you can see here, this is in a package called schoolwork. So whoever made this has a folder in their IDE called schoolwork, and that's where they did this assignment. Unfortunately, if it's in a package, then I have to run your code a particular way, which is not the way my tester is running your code. So this code isn't going to compile because of that one line. So what you want to do before you turn your code in is just double check. Does it have this line at the top, package, whatever? If it does, delete it. That's it. Don't have that line package. This is a mistake that also happens a lot for our UIL team. Same reason, they're using IntelliJ. It will add this package, and then it'll get sent to the judges, and it doesn't compile correctly for the judges. It's a very common mistake when you're new to using the editors, to just know to look. If it starts with this package, whatever, that could be anything, delete that line before you turn it in, because that will cause your code not to compile for my grader. The other part of this, so that's packages. The other part of this is imports. And there's 2 things to worry about here. Again, this is going to be at the top. If you're using an IDE like IntelliJ or Eclipse, it will auto import packages for you, which sometimes you need. And I'm going to talk about in a second when you might need one. But what that means is if you typo something that's not what you're trying to write, but maybe something that exists, or what will happen in the IDE is it'll give you a pull down, and you'll accidentally click on something to pull down. It'll write this weird line of code. I don't know what that is, and you delete it. But it's too late. The code's already imported some other code for you, and you deleted the one line, but you didn't delete all the other lines imported. If you look at the top of your file, you might see a lot of things like import something like com.sun.whatever.something. And you'll see a bunch of lines like this most likely. I'm just going to copy and paste this. Just a bunch of stuff. It won't make any sense. It'll start with import, and it'll be a bunch of something.something.something. Just delete those. You've already most likely deleted the line of code that that caused those to get imported. But now you also have to delete these lines. If you don't delete those lines, your code's not going to compile on my end again. Now, that being said, you don't always want to delete all of the imports. There is a particular case where you need an import. There's two cases for us. One of them we know about so far. If your code is using scanner, then you do need to import the code that includes scanner. So there should be a line at the top of your file, import java.util.scanner, semicolon. And when I give you your starter code, it will already have that line at the top. So if you see import java.util.scanner, don't delete that. You have to have that. But if there's anything else up there, and they'll look weirder than that. They won't say import Java. They'll say import com.microsoft.something.project.whatever. It'll be some like company name. It'll import IntelliJ.something. It'll be weird. But the only one you want to keep is import java.util.scanner. So this particular lab didn't have import java.util.scanner, but it was using a new scanner here, so it didn't compile. So yes to java.util.scanner, no to any other import statements. So just double check. So before you turn your code, scroll to the top, look at those top lines, make sure there's no package, make sure you don't have a whole bunch of weird imports, make sure if your code used scanner that it does have import java.util.scanner, which again, I'm going to put in your starter code for you so you won't have to. Just don't delete it. That's number 2. Number 3 on our top 5 list of common mistakes is method headers. So we will talk about methods and method headers and what all the details of those things are. But there's basically, for right now, you don't want to change the starter code I give you. You will add things in between the curly brackets, but you shouldn't be changing anything in the code that I give you. So one thing I'm seeing happen a bunch is if there's methods that you didn't implement, because there's 16 methods, you only do 8 or 9 of them, that you comment out the methods you're not doing. So this person did a bunch of methods, great. Maybe they work. I don't actually know, because when you got down here, the middle method, they put comments in front of all of these statements. And then the same ones method, comments in front of it, and get letter, comments in front, because they didn't write the code. So they commented the code out by putting comment lines in front of all of the lines of code for that, which is fine for you. It's going to run for you. But when my code tries to test it and it can't find the get letter method because it's become a comment instead of code, the whole thing doesn't work. Even the methods that got written, my test will fail because it can't call this method because it's also trying to call these other methods that no longer exist because they were commented out. So don't do this. Just leave it the way it is without these comments. Totally fine. You'll fail the test for this method, sure, but you'll pass all those other tests. And by commenting this out, you fail all the tests, which is way worse. So leave the ones alone that you leave alone. Don't even comment them out. Just do less, and you will get better grades. The other thing that's happening, I'm seeing, is rather than commenting out those method headers, they're getting changed. So this one, so that there's a method in here we were writing called middle. I'm going to scroll down and find it right here. And it got changed to be the method middle letter. So again, this is the same kind of problem. My code is testing a method called middle, but this code has changed the name of the method to middle letter. So now it's my tester is not going to work. It's not going to be able to call the method it's looking for. So none of these methods will work because I'm trying to test a middle method, which no longer exists, which doesn't exist. So it's going to fail testing all of the methods. So these method headers, leave them alone. Don't change them. I'm giving them to you. And it's information for you to use. Like, you're writing your code in between the curly braces, but don't change anything in that header, or else none of your code will work. It'll work for you when you run it, but it won't work for me when I grade it. And then you won't get any points for it. It's just super bummer. So it's another case of do less, right? Don't change things. Leave them exactly as they are, and you will do better that way. So that's number 3. Number 4 on my most common mistakes and errors, again in 3 parts. So let's talk about first this one right here. Print lines in methods. So when you're doing these drill labs, the idea is you're writing some method to solve a problem. You're given some inputs, you process that input, you produce an output, and you return the output. And then in your main method, you invoke that method. You call the method, give it an argument, and then print out its answer so you can see it. These print lines should only exist in your main method. You should never, ever, 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 ever write a print line inside of one of these methods that you're writing. Now, I say that, let me back up. You can do it if you're doing it to debug your code. And so if you don't know what I'm talking about, that's fine, but I know some of you do because I'm seeing you do it. The problem is if you forget to remove your debug code. Let's see if I can find it in this one. I don't know where it is in here particularly, but what happens is if in your code you've written something like system.out.println, it works. Just because you're testing your code or whatever. So you've got some print lines in here because it wasn't working. You were trying to figure out why it wasn't working. So you put print lines to track it. Totally fine. It's a common way to debug code. But if you leave this in here, when my tester goes and runs your program, it doesn't expect that text to get printed out. And that text printing out is going to mess up what the tester's doing. It's going to see that text come out and it's not going to mark this correct. It returned the correct value, but this print line comes out, makes it so I can't detect that you returned the right value. So you don't want to put this print line in here. And furthermore, this isn't just me being a weirdo about this. On the AP test, this is basically what an AP test question will look like. You'll get a comment that describes what this method does, and probably a whole page describing what it does, and you'll be given a method header, and you'll have to write all this code. And if you write the words system.out.println, you will lose points. For the most part, you start at 0, and as you do good stuff, they add points. You get points. You don't lose points. You only get points for doing good stuff, except in very few circumstances. And one of those circumstances is you wrote a print line in your code, -1 point out of 9. It's basically minus a letter grade for writing println. And if you do it a bunch of times, you're knocking off letter grades because each time you do it, you lose a point. It's a super bummer. And it's another case of don't do it and you'll get more points. Just do less things. So don't write print lines inside of these methods we're writing. Only write the print lines inside the main method, public static void main. It's the only place where you should be writing print lines. Okay, and that idea is going to come up in just a second because now I'm going to talk about scanner. So scanner is what we use to get input from the user. And again, the only place scanner should live is inside your main method, your public static void main method. So here, let's see, here there is no scanner isn't even used in the main method. Here in process, it makes a scanner, it gets the next line, and then it processes it and does a bunch of stuff, right? Whatever the lab wanted us to do. This should be way up here. And in fact, once that's there, we actually want to get rid of like all this, because all the main method for this one should do is print hello, get the user to type something, process the thing they typed, and in this case, that message should go there because that's what we want to process, and then output the response. So the scanner is in the main method here. And down here, this variable message gets whatever was processed here. So if I just write, say, a string literal, how are you? This value, how are you, is going to be assigned to this variable message. The variables in these parameters, or in these parentheses, they're called parameters. We will talk more in depth about these later, but they're variables that already have a value. You just don't know what it is. It could be anything. All you know is that message contains a string. So what you should definitely not do is ever say message equals something right at the beginning and like assign it some value right in the beginning, because then whatever the user sent in, I sent in how are you, and the first thing I did here was I changed it to tacos. So it doesn't matter what the user asked. That will break the tests, because my test is going to be passing in particular values for message and expecting a particular answer to come out. But if you're overriding it, this code's always going to say tacos are great. But what if my message was I like dogs, in which case I expect dogs are fun to come back, but I'm not going to get that because the first thing you did was change it to tacos, the message. So don't write scanner in your methods. Scanner only belongs in the public void main method unless explicitly stated in the instructions that you must write scanner in this method. But for the most part, you should never be writing scanner in your methods. And that's another place where on the AP test, if you write scanner equals new scanner in your code on the AP test, they minus points for that. There will never be a case on the AP test where they're asking you to print something or use a scanner, because all of this main method code where the printing and the scanner should happen, that's just assumed on the AP test. They're gonna say, assume there's a runner that does all this, and you don't have to worry about that. All you have to worry about is what to do with that input once we've gotten it, but not necessarily how to get that input. So in the main method, scanner and output. Anywhere else, no scanner, no output. And that brings us to the third part of this point, which is returns versus prints. So when you're writing your methods, let's scroll down here and find one of these methods. So here we're writing process I want statement. It takes a message, it processes it, it generates a new version of that message, and it's supposed to return that. So it takes an input from the parameters and it's supposed to return the output. But what this code is doing is once it figures out what the new version should be, it's printing the answer. So one of the quick things I think was asking, what's the difference between a return value and printing a value? Well, when you print a value, it gets output to the screen, to the console for the user to read. When you return a value, it comes back to wherever this method was called. It doesn't go to the screen. It ultimately goes to a variable, and it lets you do more stuff with that variable before printing it. And that's what we want to do with basically all of the methods we ever write. They're going to return a value. So your answer should always be at the end of the method, return my answer, whatever it is. Because up here, when I call the process method, it's passing message that goes into this method, which does a whole bunch of stuff. And at the very end, it's supposed to return the answer. In this case, it returns null. That was what it originally returned. And then whenever you call a method, you're going to want to store that result in a variable. So process, I call process, it does some stuff, it returns something, and the something it returns comes back and gets stored in this variable. And then I'm able to do more stuff with that variable, like if I want to print it. But maybe I could do something else. Maybe I want to say result equals result dot substring 410, and I just want a chunk of the result or something. I don't know. But it lets me do stuff to it before I print it. If you just print it here, that's it. You're done. You printed it. I can't process that data anymore. And the whole point of writing these methods, long run, is that you can kind of chain them together. And this method does a little bit. This method does a little bit more. This method does a little bit more. You can mix and match these methods to do different things in different circumstances. So you don't want them just willy-nilly printing their answers out. You want them returning their answer and then you can decide to print it out whenever it's appropriate, but not necessarily when you first did the work. You might want to print it out at the end. So inside your methods that you're writing, don't print anything. For debug reasons or for final answer reasons, you should be returning your answer. So like this could be fixed very easily by creating a string variable, just string results, give it some value, and all these print lines should actually be result equals dogs are fun. Result equals is it raining? Result equals tacos are great. And then at the very end, you just return result. And that fixes this problem that was happening here. So no print lines in your methods, no scanners in your methods. Those only belong in the one main method at the beginning. And return your answers instead of printing them. That's this point. All right, number 5, doesn't compile. Okay, so if you have any bugs at all in your code, if it does not compile, you know this because you hit the little run button and you get error messages. If you turn that in, I will also get error messages, and it's a 0. It doesn't compile, it passes none of the tests. Even if every method works but the last one you couldn't figure out, so you just left it. But if you left it with an error, I have the error as well, and it won't work. And I mean, you can go ahead and turn that in. You already know what your grade is because it doesn't work. So here we're looking, and this is actually pretty common, is the code to me looks very much like Python. And in CS1, we didn't teach Python last year, but I know a lot of you probably have learned or seen Python before coming here. We used to teach Python in CS1, and I would see this a lot more. Python's just a different language. It has similar but slightly different syntax than Java. But basically, this code doesn't compile, and this is a blatant example where it's easy to see. But often it's something very small, like I'm missing semicolon here, or reusing a variable within scope, something like that. But if it doesn't compile for you, it will not compile for me. Like there's no like, maybe I'll get some points for this. You won't get any points for that. Just clean up the errors. Like even if you have to like go back to the starter code and change the method back to the original version that wasn't implemented, go ahead and do that. Because if it compiles and you've written anything anywhere, you might get some points. But if it doesn't compile, you won't get any points. And that's, again, a bummer when you should be getting some points, but you're getting none. So that's my top 5. I do have a bonus thing so that I've seen. Now, this isn't necessarily costing you points. I think people are actually getting points for doing this. But long term, this is possibly going to hurt you or trick you, especially when it comes to the AP test where you're answering on paper and you can't compile it to check it. And there's just some stuff that's going to get you. And what this bug is using the char at method instead of the substring method to isolate single characters. And the char at method solves this problem. If you need to get one character out of a string, you can use the char at. It gets you the character at an index. And it seems super easy. Here's the problem. I'm not teaching you char. Char is not one of the primitives that we use in this class. And there's some weirdness to it. Char is technically a number. And you think of it as a single character, but it's not. It's a number, which can make some weird things happen, not at the char at level, but what you do with that char afterwards. So I'm just going to go through real quick and show you some things of why you're using it, but then why you're not. And even though I'm going to show you what the bug is, when under pressure on a piece of paper without a computer, you're probably going to fall into this trap when it hits you. It's happened on an AP test a couple years ago, and a lot of people got this question wrong because of using char at, and it just didn't do what they expected. So I've got this string called banana, and I'm getting the letter at index 1, and I'm doing it using char at, and I'm doing it using substring. These are effectively doing the same thing. This is getting me the character at index, and this is getting me a string of length 1 starting at index. So from index to index plus 1. This is how I expect you to isolate one character from a string. This is what I'm teaching in the class, and this is how you should expect to see it in questions, and how I expect you to give it back to me. So to start with, I'm just going to print out. I'm going to compile this. See, compile it. I'm going to hit run. And down here, you can see the char version is A, and the string version is an A. That's what I'm having it print out. The char version, the value of C. The string version, the value of S. Okay, so they're both the same thing. The next thing I'm going to do is I'm going to use equals equals to compare the char C to the char literal A. So I'm going to compile. Ooh, and I've got an error there. Try that again. Still error. Cannot find symbol. Line 17. Oh, I misspelled println. Println. There we go. Compile. Run. So now we print out char A, string A, and then compare char true. So when I say C equals equals the char A, which has single quotes, you don't have to remember that because we're not learning chars in this class. That's true because up here, like we're showing you right here, char has A in it. I compare that to A. That's a true statement. Now if I comment out this line, which is doing the same thing but with my compare stir, so it's using equals equals to compare S, which is the thing I got with substring, to the string A, run, and that is false. Even though up here it says the stir A, compare stir, comparing it to A, why is that false? Well, we had that whole class about references, right? S contains a reference to the string with an A in it, and this string A here is a reference to another. They're both A, but they have two different addresses. So equals equals is comparing the addresses and saying these aren't the same addresses. So that's not what we want to do. Because remember, when we compare strings, we don't want to use equals equals. We use the dot equals method. So if I change that to using dot equals and I say S dot equals A, I compile that. I run that. Now it says compare stir is true. So this is one of the reasons why I think I'm seeing people use char at, is because you can use equals equals and it works. Whereas when you use the substring method, you have to use dot equals to compare those strings. But like I said, on the AP test, they will not test you on char. They're going to test you on strings. And if you are solving all these problems using chars and equals equals, when you start having to answer questions about strings and dot equals versus equals equals, you're more likely to get that wrong because you haven't been practicing it. Furthermore, there are some issues that happen with chars. So it's not all gumdrops and, I don't know, candy bars. So here I'm doing some concatenation. So I've got my char C and my string S. So remember, char C is the letter A, and my string S also has the letter A. So I just uncommented this all. I'm going to uncomment this first print line. I'm going to compile. I've got an error already. Incompatible types. Int cannot be converted to string. Okay, so when I combine two chars, right, this probably should be a char, not a string. That makes sense. Compile. Incompatible types. Possible lossy conversion from int to char. That's weird. So it's telling me when I add a char to a char, I'm not getting a char back. I'm getting an int back. That's weird. Because I would expect if you have A and you concatenate A, you get two A's, right? That's what you'd expect. If I compile this now, I fixed it to an int because that's what it told me to do, and run it. So when I say char A plus char A, that is 130, the number. Okay. But when I say S plus S, and remember S is a string with an A in it, and I run it, I get AA. So what's going to happen on the AP test is you're going to be getting these characters out and you're going to be concatenating them to something to solve some bigger problem. Okay. And when you have the substring version, which are strings, and you concatenate, it's going to work. You're going to get these letters concatenated together, just like you expect. But if you have used charat and you've gotten chars and you try to concatenate them, you're not concatenating, you're adding chars together and getting int values, which is not what you expected at all. And that's going to lead to a wrong answer. And you won't even know because there's no way to compile your AP test answers because you're writing it on a piece of paper with a pencil. So it's just a wrong answer. And that ends up costing you, depending on how the rubric is written, 1 to maybe 3 of the 9 points, because it basically just does not work right. On the test, they give you some leeway when you're using the stuff that I've taught you. But if you go out of the scope of the class, if you use chars, and we never learn chars, it's fine as long as you do it right. But there isn't leeway for you were close with the out of scope stuff. It's either you did it correctly or you did it incorrectly. If you were using substring here and you were close, you're going to get more points than if you were close with chars but not correct. So anyways, I do not recommend practicing tools that we're not learning in class to solve the problems for class, because I'm giving you these problems for a reason, because they're the things you're going to see and be responsible for on the AP test. And there are a lot of ways to solve all of these problems, and there's multiple methods you could use to do it. For instance, you could use charat or substring to isolate a string, and there's reasons to do it either way depending on the problem. But for our case, since we're only learned in class substring, you should be using substring instead of charat, because otherwise you're learning a whole subset of skills that you're also learning on your own. Because if you're using charat, you're like, Mr. May didn't teach me any of this. I don't know any of this. What's going on here? Why didn't Mr. May teach me? It's because I'm not going to teach you chars. You don't need them. You only need the stuff that I've showed you. And it can be solved with them. I just don't recommend it for the class, because there's always these weirdities like how concatenation works that maybe you don't realize and you don't run into it until it's too late. So that is my rant about chars. Again, use them at your own risk. I don't think anyone got anything wrong yet for using chars. I just am seeing char in a lot of the answers, and it's possibly going to lead you into weird situations down the line when we start doing more complex problems with letters. So that is my top 5 plus a bonus, most common mistakes. So hopefully you can learn from these, not make these mistakes in the future, and fix these mistakes that you maybe have been making in the past, so that you can start getting the points you deserve for these labs. I guess a real quick summary is look at the top of your file before you turn in. Make sure there's no package. Make sure there's no weird imports. Make sure if you use scanner, it does have the scanner import. If you are copy and pasting your code into Turner Inner, don't change the file name. Keep it as the correct file name that it auto detects, so that it will compile for me. Make sure your code compiles. Don't turn in code that doesn't compile, because you already know you're not going to get any points. Or turn it in. I mean, it doesn't matter, but just know you're not getting any points if it doesn't compile. Don't write scanner or print line in the method you're writing. Only put those into the main method. And don't change the method headers that I give you. Don't change the method names. Don't comment out those methods. Even if you don't implement them, just leave them. And in not that order, that's the summary. So I will stop talking now. Thank you for listening.